Good afternoon, class. We are looking at Chapter 4, Applications of Derivatives, Section 4.6 Antiderivative. We've done a big chunk of it, and now we're going to look at more examples here. So we want to integrate 2x to the power of 4 plus 3x cubed minus 7x squared plus x minus 5. So we're going to do it term by term. This one is 2 over 5x to the power of 5, 3 over 4x to the power of 4, minus 7x minus 7/3 x cubed. This one has exponent 1. So 1/2 x squared. And finally, minus 5x plus c. We're going to raise this to the power of 2, becomes x squared minus 10x plus 25 times dx, of course. X squared gives us 1/3 x cubed. Again, this one has exponent 1. So negative 10 over 2 makes it minus 5x squared plus 25x and a constant. In this case, we make up 3 fractions. This is 1. This is minus 7 over x. This is 2 over x squared. And for the second piece, we're going to write it as minus 7 times 1 over x. And the last piece, 2x to the power of minus 2. So this, the answer is x. This one is minus 7 ln x. And what about this one? We are going to write the steps as follows. 2 divided by negative 2 plus 1, x to the power of negative 2 plus 1, which makes it 2 over negative 1, or minus 2 over x, and a constant. For this one, what I want you to notice, dt is telling us the independent variable is t, so the integral of 1 is t. Cosine, the derivative is negative sign, but the integral is positive sign, so plus sine t and a constant. Cube root of x minus sine x, cube root of x. Even if we are differentiating, we are going to change it to x to the power of 1/3. Now we can use the power rule on that. In this case, would be 1 over 1/3 plus 1, x to the power of 1/3 plus 1. And minus sine, the derivative is cosine, the integral is negative cosine. So minus negative cosine x plus a constant. So 1/3 and 1, they add up to 4/3, and this would be 3/4 cube root of x to the power of 4 plus cosine x plus a constant. Solve the initial value problem. dp dt is 2e to the power of 3t, p of 0 equals 1. This makes it the initial value problem. So first, let's look at the following. Any equation containing a derivative is called a differential equation, or DE. A function which satisfies the equation is called a solution to the differential equation. An initial value problem is a differential equation along with a specified value of the unknown function called the initial condition. In other words, if we ignore this for now, dp is the right side times dt. If we integrate both sides, the left side becomes p of t. For differentiation, we multiply by 3. For integration, we divide by it. And what you're looking at is called the general solution. This is the indefinite integral because we don't know what the constant is. It is also called a family of functions. And if we didn't have this, we would be done. But we do have this pair 0, comma 1. We're going to replace p of t or y with 1. We're going to replace the t with 0. As you know, this is e to the power of 0 or 1. So 2/3 plus what number gives us 1? It's 1/3. Here's the answer. And now this is called a particular solution. So the idea is that when you integrate, you get a general solution, a family of functions, indefinite integral. Indefinite because we don't know what's the constant. Any pair will help us find the constant. It becomes a specific solution, a particular solution. If we look at this example, dy dx is 1 over x plus 1 over square root of x, where y is 5, x must be 1. In this case, dy is the right side times dx. If I integrate both sides, this becomes y, and the right side we are going to integrate by changing this to x to the power of 1/2, bringing it up makes it negative 1/2. So this, of course, then answer is natural log. This one is 1 over negative 1/2 plus 1x to the power of negative 1/2 plus 1 and a constant. So this gives us ln x. This gives us 1 over negative 1/2 plus 1x to the power of negative 1/2 plus 1 and a constant. Negative 1/2 and 1. They add up to 1/2. The reciprocal of this is 2, and then it's 2 square root of x and a constant. And again, you're dealing with a general solution. So we have the pair 1, comma 5 we are going to plug in. When we do that, of course, ln 1 is 0, this is 1, so 2, and what number they add up to 5? The answer is 3. You put it in here, and now you are dealing with what's called a particular solution. Pretty straightforward, everybody. Initial value problem. One more here. We want to find f of x such that f of 2 is 1 and capital F prime is 3x squared plus 3x plus 7. So if you integrate this one times dx is f of x. A simple integration, this is x cubed, this is 3/2 x plus 7x and a constant. And so what you're looking at, again, we are looking at the general solution, everybody. This one gives us the pair 2, comma 1, and we're going to plug in. Two cubed is 8. 4 divided by 2, 2. 2 times 3 is 6. 6. 7 times 2 is 14. And so if you look at these numbers, add up to 28. 28 and what number is 1? Negative 27. You are going to replace this, and now we have a particular solution. In other words, we have an indefinite integral, we have general solution, we have a family of functions, we have infinitely different functions because of the C. However, one pair will help us find the C. It gives us one of those solutions. It's called particular solution. To do this integration, we are going to make up two fractions, x over square root of x and 1 over square root of x, where square root of x changes to x to the power of 1/2. X to the power of 1/2, everybody. Uh, this has exponent 1, so this is x to the power of 1 minus 1/2, which makes it x to the power of 1/2, and the other one is simply x to the power of negative 1/2 dx. To integrate, we are going to say the answer is 1 over 1/2 plus 1, x to the power of 1/2 plus 1 for this one. This one is 1 over negative 1/2 plus 1, x to the power of negative 1/2 plus 1. 1/2 and 1, they add up to 3/2. Negative 1/2 and 1, they add up to 1/2. Division by 3/2 means multiplication by 2/3. Division by 1/2 means multiplication by 2. So the answer is 2 x to the power of 3/2 over 3 plus 2 x to the power of 1/2 plus c. And of course, this is a general solution. Example 7, a sample of cesium-137 with an initial mass of 79 milligrams decays T years later at a rate of negative 1.8249 e to the power of negative 0.0231 T milligrams per year. Find the mass of the sample after 23 years and round it to 1 decimal. First of all, what is the mass? Let's say m of t is going to represent the mass. This is its derivative, dm dt, or m prime of t, because it's the rate. This is the initial value, m of 0 equals 79. So we can go through the process to find m of t, and then we plug in 23. So dm dt is this, m of 0 is this, m of t will be found, replace the t with 23, we have the answer. So if that is the case, what is, if dm dt is that, then dm is the right side times dt, and m of t is the right side times dt. Take an integral. In essence, this is an initial value problem. So m of t is the integral of negative 1.8249 e to the power of negative 0.0231 t, and then times dt. When we differentiate, we multiply by this coefficient of t, but for integration, we're going to divide by that. And the division will result in 79. So here's m of t in general. M of t is 79 e to the power of negative 0.0231 t plus a constant. And we have one pair, which means if I replace the t with 0, this gives me 79. When I replace the t with 0, the exponent becomes 0. E to the power of 0 is 1. So this is 79. 79 is 79. And what number? C becomes 0. And now this function is just m of t equals 79 e to the power of negative 0.0231 t. We want m of 23. Replace the t with 23. That means this is now 23. Put it into a calculator with a bunch of decimals. And then it says 1 decimal. So I need the 4. Look at the right side, because it's 3, it's not going to change. If it's 5 or above, this changes to 5, but it doesn't. It remains unchanged. 46.4 milligrams is the final answer.